Page 268, Lesson 4.6 is on formalizing relations and functions. So a little bit of vocabulary here. One thing is we can talk about a relation, which is a pairing of numbers in one set called the domain with the numbers in another set called the range. So domain is the x values, range is the y values. And then when they're paired together, that forms this relation. In a function, it's a special type of relation where each value in the domain is paired with exactly one value of the range. So if you have one certain x value, you're just going to have one y value that goes with it. A way of thinking about this, it's kind of like if you're cooking something, if you're baking something, let's say you're going to bake some cookies. So you mix these certain ingredients together, which is like your x value. And then when you cook this thing, you put it in the oven, you open it up, and you're going to get one certain thing. Let's say you're making chocolate chip cookies. When you're done, when you get that out of the oven, there's one thing you're going to get with those ingredients, which is chocolate chip cookies. It's not like, oh, I might get chocolate chip cookies or I might get meatloaf. Okay, if you have one certain set of ingredients, you're only going to have one output. You're only going to have one thing that you're going to get out of that in the end. So that's a way that can help you think about a function. So problem 1, they talk about using mapping diagrams. Mapping diagrams, they put the domain or the x values in one kind of oval, and then the range, the y values, they put in another oval. And then they just draw arrows to kind of show how this works. So if we have negative 2.5, notice from negative 2 we have a line, an arrow going over to 0.5. 0 goes to 2.5. 4 goes to 6.5. And then 5 goes to 2.5. So the question is, when we're looking at this, if we have a certain domain, if we have a certain x value, is it only going to one y value? So negative 2 is only going to one y value. 0 is only going to one y value. 4 is only going to one y value. And 5 is only going to one y value. And you might look at that and you might say, well, the 0 and the 5 are both going to the same y value. That's okay. As long as we have certain x value, it can only go to one y value. And here's my explanation for that. You might say, well, you talked about ingredients, and if you have certain ingredients, it's going to make one thing. Okay, let's just generally say, let's say if 0, this is like chocolate chip cookies, and 5 is like raisin cookies. Both of those, generally, we could say make cookies. So let's say 2.5 is like cookies. So this set of ingredients makes cookies, this set of ingredients makes cookies. They're a little bit different, but they're both cookies. And that's okay because the x value is only going to one y value. So that is a function. If you look at the second one, they mapped out, and they kind of just looked at this, looked at the x values and said, okay, we've got 4, 5, and 6. They just put them in order. And then they would put the y values in order also, 3, 4, 5, and 8. Okay, and now they're pairing them up. So 6 goes to 5, 4 goes to 3, 6 goes to 4, and 5 goes to 8. And here we've got a problem. 6 went to 4 and 6 went to 5. So that's the same x value, two different y values. That's like our ingredients are making cookies and meatloaf. That doesn't work. So that is not a function. Okay, and they're doing this using mappings. You don't have to do mappings in order to tell this. You could just look at this and say, oh, we've got 6, 5, and we've got 6, 4. That's the same x value, two different y values. It's not a function. So the got it one, they want us to identify the domain and range. and represent it with a mapping diagram, and then they're asking whether it's a function. So since it says to use a mapping diagram, we will go ahead and do that. So domain, sometimes you can just use a capital D for domain. Domain is the X values. Usually they go in order from least to greatest, just so you know. If you don't put them in that order, it's not wrong. It's just, it makes it easier for you if you list them in the same order as the book. So 4.2, 5, and 7 would be our X values. That's our domain. And then the range, the Y values, we've got 0, 1.5, 2.2, and 4.8. Okay, then we need to do a mapping. So for the mapping, we've already got these in order. And then we're just going to draw a line. So 4.2 goes to 1.5, 5 goes to 2.2, 7 goes to 4.8, and 4.2 goes to 0. So right here we've got a problem again. We've got the same X value going to two different Y values, so this is not a function. Part B, same idea. Domain, we've got -2, -1, 4, and 7. In the range, we've got negative, well, in order I guess, -7, -4, 1, and 2. So now we map these out. So -1 goes to 1, -2 goes to 2, 4 goes to -4, and 7 goes to -7. So that is good. We got all different X values, so that's going to work out. We do have a function. Another way to see if something's a function is what's called a vertical line test. Vertical line test is if you already have something graphed, or if you wanted to graph the points out, you could, and then you can draw vertical lines. And if you draw a vertical line, if it only hits your graph one time, then it's a function. If you have it every time you have a vertical line, either you don't have anything there or it's only going through one point, then it's a function. Because what that means, if you draw a vertical line, that vertical line, all the points on that vertical line have the same X value. So for everything with the same X value, if you only have one point there, it means you only have one Y value for that X value. So if you look at problem 2, part A, they graphed those points, and right here we've got a problem because there were 2 points here. Okay, and that represents, we've got -4, 2, and we've got -4, -1. Okay, and so not to say you have to graph it if you were given these points and you can just recognize, you know, that's two different Y values for the same X value. But this is a more visual representation that you guys can see visually what's happening here. Part B, this time if we would draw vertical lines, these are only hitting the graph one spot. So that does pass the vertical line test, and so that is a function. Okay, so they got it 2. we could do the same thing and graph those points. So for part A, if we graph those points out, you can see if you draw vertical lines where those points are, they're only hitting one point, so that is a function. So we could say yes, it is a function. And then part B, similar idea. If we graph this, okay, and if we draw vertical lines, we can see here there's a problem. We've got 0, 2 and a 0, negative 3. Oh, I graphed that one wrong, sorry. That was 0, negative 3. I graphed 0, 3. Okay, anyway, that has 2 points on that y-axis, 2 points on that vertical line, so that is not a function. The next thing the book talks about is what's called function notation. Function notation is just another way of writing something. It's just saying it is a function. It's basically saying y is a function of x. And like the book says, f of x is replacing y. Okay, so instead of writing y equals negative 3x plus 1, they can put f of x equals negative 3x plus 1. If that's confusing to you, when you see f of x, you could just put a y there. The reason they do this sometimes is to show when they evaluate something. Oh, and by the way, you can use other letters. I think they do f for function, but you could use g of x or h of x. Problem 3, they're using w of x. So this is the number of words you can read in x minutes. How many words can you read in 8 minutes? So the reasoning of them using function notation is they're then showing what they're substituting in. Okay, so instead of saying like y equals 250x and then saying if x equals 8, then I'm going to substitute and work that out. Okay, it's just a little different way of doing it. Instead of saying x equals 8, working it out, instead of that, we say, okay, we have this function, it's w of x. Again, this could just be a y here. But they're just saying we're putting an 8 in place of the x. You don't do anything. If you do it this way, you don't do anything with the left side. It's not like it's w times 8. It's just saying we're substituting an 8 in place of the x. So substitute 8 in place of the x. 250 times 8 is 2,000. So that means we can read 2,000 words in 8 minutes. The got it 3 is very similar. So nothing real exciting here, I guess. But if you start with that equation, how many words can you read in 6 minutes? So we just put a 6 in place of the x. Again, not doing anything with the left side of the equation. 250 times 6, which is 1,500. So we can read 1,500 words in 6 minutes. Problem 4, it talks about finding the range of a function. So they tell us the domain is 1, 2, 3, and 4, and they're asking what is the range. So what we're going to do, the domain is the x values, so we're just substituting those x values into the equation and then seeing what y values you get. Okay, and again, instead of f of x, I don't have to cross that out, I guess, but instead of f of x, this is the same as y. Okay, so these are our y values. So you put a 1 in place of the x, and they get 2.5. Put a 2 in place of the x, and they get 1, and so on. So all of these then are our y values. These represent the range. And so that matches up with answer choice A. So the got it 4 is not multiple choice, but same idea. They're asking what is the range. So if you want to have something like this, and you can do a y or you can do a g of x here, whatever you want to put. So we've got 1, 3, 5, and 7. So we're just substituting those in. So this would be 4 minus 12, which is negative 8. And it's however you want to work it out. If you want to do that middle column, or if you just want to work it off to the side. 12 minus 12 is 0. 20 minus 12 is 8. 28 minus 12 is 16. Okay, so the question is, what is the range? So we could say the range is negative 8, 0, 8, and 16. Problem 5 is identifying a reasonable domain and range. So if you have 3 quarts of paint to paint the trim in your house, and a quart of paint covers 100 square feet, they have a function that represents the area that Q quarts of paint covers, and what domain and range are reasonable for the function, and what is the graph of the function. So if we think about this, 1 quart of paint covers 100 square feet, and we have 3 quarts. So that would mean that would be 300 square feet that we could cover. Look at what's the least amount of paint and the most amount you could use, and what area would that cover. Okay, so for the paint we could use between 0 and 3 quarts, and then we could cover between 0 and 300 square feet. Okay, so reasonable domain would be from 0 to 3, and a reasonable range would be from 0 to 300. And then we could graph that. Obviously putting 0 and 3 in for x, finding those endpoints would be good, and then maybe finding one other point just to make sure that those line up with each other. Problem 5 is very similar. If you have 7 quarts of paint, what domain and range would be reasonable? So the domain, we would be between 0 and 7 quarts of paint, and then the range would be between 0 and 700. 7 times 100 would be 700 square feet. Okay, and they're just using Q for quarts. A of Q just means that's the area. Area is the function of how many quarts of paint that we're using. Look at the lesson check number 1. Identify the domain and range. Represent with the mapping diagram, and is it a function? So we do that like we did earlier. Domain is just the x values, -2, -1, 0, and 1. And the range is 3, 4, 5, and 6. And then if we do the mapping on that, this one conveniently goes straight across, so it's not quite of a mess. So then we could say, yes, that is a function. Each x is only going to one y value. Number 2, they ask if that's a function, use the vertical line test. So if we just draw vertical lines here, those are only hitting in one spot, so we could say, yes, that is a function. Number 3, f of 2, we're just substituting. Instead of an x, we're putting a 2. Okay, it's just like if we had y equals 4x plus 1, and then they said, well, what if x equals 2? It's the same idea. So 4 times 2 is 8, plus 1 is 9. So we could say f of 2 equals 9, which just means if you put a 2 in place of x, you get 9. And number 4, They tell us what the domain is. They're asking what the range is. So we're just substituting those numbers in. So if you put in a -4 for x, half of -4 would be -2. Half of -2 would be -1. Half of 0 is 0. Half of 2 is 1. And half of 4 is 2. So the range would be -2, -1, 0, 1, and 2. Number 5, they want us to write this using function notation. So function notation, instead of a y, we can put f of x. So f of x equals 2x plus 7, and that's all they want us to do there. Finally, number 7, a student drew the dashed line and concluded the graph represented a function. Is the student correct? So we can do this since it's graphed. We can use the vertical line test. So I think if you look at this, what the student did, they drew a vertical line here and said, yep, it only passes it one time, so it must be a function. What you want to do, you want to keep drawing vertical lines across the graph, and you can see here is a definite problem. We've got 3 y values for the same x value, so that can't work, and that can happen other places too, or at least 2. You know, some of them maybe there's only 2, but if there's more than 1, it's not going to work. So that is not a function, so the student is not correct. So this gives you an idea of working with domain, range, mapping, and functions. Have a good day.